early binding. In the early binding, the compiler matches the function call with the correct function definition at a compile time. Okay, so in early binding, compiler matches the function call with the correct function definition at a compile time. So it is also known as a static binding or compile time binding. By default, the compiler goes to the function definition which has been called during the compile time. So all the function calls you have studied till now, these are due to the early binding only. Means whatever uh, functions we are calling with the help of the object, that all are done at the compile time only, and that's why these are called as an early binding. So we have already studied the function overriding concept. So I hope you understood, or you still remember what is function overriding. So in which the in function overriding, what we are doing, the base and derived class have the same function name. So it is the function overriding concept we have used in inheritance concept, where in the base class as well as the derived class have the functions, and these functions are having the same name, same parameters and return type also. So that concept is called as an function overriding. So in that also, in function overriding also, the early binding is done. So with the help of the same concept, that is function overriding, let's see, or let's understood the example of the early binding first. So we will do one example or one program here. So in the same program, I'll make some changes, or we'll do new file. Okay, so hash include iostream.h conio.h. Okay, let's take an one class as a class A. In that public, I'll make one method void show. Okay, in that print one message as a cout in class A. Complete the class. Again I will make one more class as a class B, which is derived from class public A. Okay, in that also again in public area, what we will do, we will make again the same method as a void show. So this is called as a function overriding, because void show method is present in parent class as well as the child class, that is class A as well as class B. Okay, so it is nothing but the function overriding. So in class B, so that message we have printed over here. Okay, in class B. Now let's write an main method, integer main. Okay, then clear screen. Now here what we have to do, we will use a simple pointer concept. So we will first create a pointer of the base class. So our base class is A, and for this I will create a pointer P. Then we will create an object of a derived class as a, we are having B and B1. Okay, B1 is an object of a derived class. Now what we can do, we will store the address of the base class object, that is B1, in pointer variable. Okay, so P is equals to and B1. So that we will do. After that, due to this, that is storing the uh, object into pointer, the pointer P started referencing to the object B1 of the base class. with the help of this, what we have done is we have just we have just done that p is equals to and b1. With the help of this, the object b1 is assigned to the p, that is nothing but p has pointed pointed pointing to the class b, or the base class or the object of a class b. Okay, now what we have to do is that with the help of this pointer we will call the method as a void show. The show method is available in both class A or the parent class as well as the child class also. So which method it will call? So it will just call the method of a parent class, because the method is being pointed by with the help of the pointer, and we have created the pointer for a parent class, so it will point to the parent class only. Okay, so sorry, return 0. So this show method is being called from the parent class only. Okay, so we will get an output as a in class A. So let's check. Okay, in class A. So this is the output for this program, and it is called as an early binding. Okay, so that we have done. Now next concept is the what is mean by the late binding. Okay, so late binding, so in the early binding, in the case of the late binding, the compiler matches the function call with the correct function definition at the runtime. Same thing is happening as like a early binding, only difference is that in case of the late binding, the compiler matches the function call with the correct function definition at its runtime, not its compile time. It is also called as a dynamic binding or runtime binding. In late binding, the compiler identifies the type of the object at the runtime and then matches the function call with the correct function definition. By default, early binding takes place. So, if by any means we tell the compiler to perform the late binding, then the problem in the previous example can be solved. This can be achieved by declaring the virtual function. So by default, compiler is executing the early binding only. Okay, so if we want to do the or if we want to make the compiler late binding, then we have to use the concept of a virtual function. Okay, so let's see the same example for the late binding. So what we will do, we will use the same example so that you can get understood what is mean by the late binding. So same example, for this example we are getting the output as a in class B. Now we have to do the late binding, so for which we will make take an help of a virtual keyword over here. So what we will do, we will make it as a virtual void show. Okay, so what we have done here, the function show of the base class we have made as a virtual. So as it is made as a virtual, the compiler performs the late binding on this function. Okay, so void show we have made it as a virtual. So whenever compiler encounters the virtual keyword, so the compiler will do the late binding for this void show, and it will now the function call will be matched to the function definition at the runtime. And since the compiler now identifies the pointer p is referring to the object b1, so we have made the same program. Okay, pointer p is pointing to the object b1 of the derived class. It will call show function of a derived class only. Okay, so what we have done, virtual we have made as a parent function, and now whenever compiler finds this virtual keyword, what it will do, it will make the this function it as a late binding, and as we have made p is equals to and b1, and b1 is an object of a class b. So this function p show it will execute the function from a derived class only, and this concept is called as an late binding. Okay, so now we will get an output as a in class b. Okay, so you can see, so this is called as an late binding. Okay, so I hope you understood. If we remove this virtual keyword, then compiler is doing early binding. Okay, so in class a we are getting, and when we are making this function as a virtual function, at that time compiler make this function available as a late compiling, and with the help of this p show it will point exactly the show function for which we have made the object, and we have made the object for a derived class. So for this case we are getting the output from the derived class only, and it is called as an late binding. So this is late binding. Next point is nothing but pure virtual function. A pure virtual function is a function which is declared in the base class but not defined in the base class. Okay, so what is the meaning of a pure virtual function is, that is, it is a function which is only declared in the base class but not defined in the base class. Generally what happens, whenever we declare any function in a class, we define that function with the same class reference, but in case of the pure virtual function, the function is only declared in the base class without any code, and it is redefined in and declared in a derived classes. Okay, so pure virtual function, it is only declared in a base class, but the code or the definition of that function is not written in a base class. Okay, so the pure virtual function is designed for inheritance purpose only. Okay, so obviously base class, derived class, these concepts are from the inheritance only. So this pure virtual function is designed only for the inheritance purpose. The pure virtual functions are declared in the base class and again redefined in its derived class only. Okay, so the whenever pure virtual function it is declared in the base class, its definition is written in a in its derived class only. It is also called as do nothing function, because in base class we are just declaring the function without doing anything. So that's why this pure virtual function is also called as an do nothing function. The syntax for the pure virtual function is virtual keyword, then return type, and the function name is equals to 0. So that is the syntax for the pure virtual function. So for example, virtual keyword, then return type is void, then display is equals to 0. So that is pure virtual function. Next, abstract class. Pure virtual function and abstract class, they both are related with the each other. Okay, how? So a class which contains pure virtual function in it is called as an abstract base class. Okay, the class which contains a pure virtual function in it, then such class is called as an abstract class. Abstract base class never allows to create object of it. Okay, so when if there is a class, that is class a, and in that class suppose I have declared one function as a pure virtual function, and whenever I declare the function as a pure virtual function, that particular class will become as an abstract class. And if the class becomes an abstract class, at that time that class never allows to create object of it. So that is the restriction for an abstract base class. Abstract base classes are used to create a base class pointer at runtime